This is Jack Jackson back with the second of our series of videos on how to find exact values of trigonometric functions of certain special angles. So these techniques only work for certain angles. Now remember, we have our basic definitions given here of sine, cosine, tangent, and secant, cosecant, and cotangent. If you know any point on the terminal side of a angle in standard position, its coordinates are x, y. Let r be the distance to the origin, that is the square root of x squared plus y squared, and these ratios then define all 6 trig functions. These are natural extensions of what we did in our exploration and work with right triangle trigonometry. So now we can extend our definitions beyond acute angles to talk about trig functions of other angles. Now, what we're going to be doing in the next, this video and the next 2 or 3, is we're going to be looking at some special triangles. And the special triangles that we have, with the same scale that we have here, are these specific triangles here. And if you click on this link that says Link to Special Triangles, it goes back and it shows how we derive those special triangles by looking first at a right isosceles triangle. Now remember, if 2 sides are the same length, and then you have radius r, the calculations here show that r is the square root of 2 times whatever the length of the side x is. Okay? Similar, well, actually that's the one we're going to use in this particular video, and so we're looking at it here. So in particular, we could let one of the sides be length 1, and the hypotenuse then would be square root of 2. Of course, if it's isosceles, then not only does it have 2 sides that are congruent, it also has those 2 acute angles are congruent. Remember, all the angles add up to pi in any triangle, but pi over 2 is taken up by the right angle. So in any right triangle, the 2 acute angles are complementary. That is, they add up to pi over 2 radians, so half of that, split it equally, would be pi over 4 for each. Or do the same thing in degrees. These 2 always add up to 90 degrees. The 2 acute angles add up to 90 degrees in a right triangle. So split that evenly, that's 45 degrees. So a 45 degree, 45 degree, 90 degree triangle, or a pi over 4, pi over 4, pi over 2 triangle has sides in the ratio 1, 1, and square root of 2. So I'll click on this, takes us back to where we were just a minute ago. And so we're looking at this triangle here on the left, this triangle right here. Okay, so actually let me just hide this one. We're going to look at this one and this triangle over here in a later video. So let me hide that for the moment and just look at this triangle here. So what we want to do is place this triangle here and so that we have an angle of size pi over 4, or perhaps we'll rotate it or flip it around and put it in here so that we always have one of the vertices at the origin. We want to make this our reference triangle essentially, and so we may have to rotate it or reflect it or move it around a little bit, but we always want one vertex at the origin, the right angle on the x-axis, not at the origin but somewhere else, and so this will be our reference triangle. Okay, so hide that. And so when we do this, our reference triangle will be pi over 4. So if we go to this one that says 3, pi over 4 reference, I can click that, and this shows you the angles with the orange here. Hopefully you can see those here and here and here and here. Those are the terminal sides. Of course, the initial side is always on the x-axis, and so any angle that has those things as terminal sides will have a reference angle of pi over 4 radians, or 45 degrees. Now we can look at this on a unit circle, but it's actually better if we can look on it at a circle of radius 2, because remember, when we're looking at our special triangle, okay, our special triangle here has the hypotenuse is going to have to be the radius of our circle, and if we let the sides be 1, that works out very nicely, and that gives us a hypotenuse of square root of 2. So it would be better if we draw a circle of radius square root of 2. Notice that's a little bigger than the unit circle. The unit circle has a radius 1, square root of 2 is a little bit bigger than 1, approximately 1.414, and so we're going to look at not the unit circle, but a circle of radius square root of 2. Now what we're interested in is these 4 points where the terminal side, the 4 different potential terminal sides meet there. And so what we're going to do is we want to find those points. Let's see. And so now you can see the reference triangles. Notice that the hypotenuse is the square root of 2 in each case. What I've got labeled on the x-axis is the x-coordinate, so the length there is positive 1, and the length here is positive 1 going from the origin out to this yellow point here, and the length is positive 1 going here, but the x values over here for the ones in the second and the third quadrant, the x is negative 1. So I've got them labeled actually with the x values rather than the lengths. So you can see the x, y, and r of all those points. So for example, let's just take them one at a time. Let's look at the one here in the first quadrant. So how could you get there? Well, we could get there by, say, rotating like this, an angle like that, and that's an angle of pi over 4, or 45 degrees. I could also rotate the other way. That would be pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4, right? Or in other words, pi over 4 minus 2 pi. Or we could rotate around what? Even more. Around even more. 2 or 3 or 4 or 5 or 6 times, whatever. As long as we end up here for a terminal side, then that's what we're dealing with. Okay, so we're looking at this angle right here at the moment. So one possibility is pi over 4 for the angle, not the only one. It's pi over 4 plus multiples of 2 pi, integer multiples of 2 pi. But either way, it goes through this point. What are the x and y coordinates? Well, look at it. X is 1 and y is 1. So that's just the point 1, 1. And then r is the square root of 2. Well, I can use that x, y, and r then to find the trig functions. The cosine of pi over 4 then is x over r, which is 1 over square root of 2. Sine is y over r, 1 over square root of 2. Tangent is y over x, that's 1 over 1, which is 1. Secant is r over x, so that's square root of 2 over 1. Cosecant is r over y, that's square root of 2 over 1, which is square root of 2. And cotangent is x over y, which is 1 over 1. Now notice I prefer to just leave it like that. So for example, the cosine of pi over 4, or if you did it in degrees, the cosine of 45 degrees was 1 over square root of 2. But some folks like to rationalize the denominator. So we could multiply the top and bottom by square root of 2, and the bottom, square root of 2 times square root of 2 is just 2, and of course 1 times square root of 2 is square root of 2. So you might see it written as square root of 2 over 2 instead of 1 over square root of 2. In fact, your computer program perhaps might accept both answers, or it might ask for this one here. I kind of prefer this one here, but either one is correct. But of course, if you're doing the computer-based homework, you got to be sure that you put in the form that they want. Okay. Similarly, let's look over here at the one in the second quadrant. So now we're going to rotate around. And so where are we rotating? We're rotating from here. And what are we doing? 1, 2, 3 times pi over 4. And we're choosing our point to be the point right here. And if we do this right, then, let's see if I can get this any better. We should get, that's pretty close right there. We should get an x of negative 1, y of 1, which you can kind of see I'm approximately there right here. And so then this will be, that x will, the radius is square root of 2, so the cosine is that x over that radius. And so that will give us the sine. And this y over that radius is this. So what are those exactly? Well, exactly it's 1 over square root of 2 for sine, and negative 1 over square. that's not right. Something is wrong with this over here. This one is, maybe I've got these mislabeled. Yeah, they're backwards. So let me label that correctly. So this one is actually sine of u, and this one is cosine. Okay, that's better. And then hopefully I've got tangent correct. Okay, so anyway, there it is. The x and y are, x is -1, y is +1, and r is square root of 2. So again, we can look at the trig values you can see right here. And so cosine is x over r. That's -1 over square root of 2. Sine is 1 over square root of 2. Tangent is y over x, so that's -1. Secant is r over x, that's square root of 2 over -1, or negative square root of 2. Cosecant is r over y, so that's square root of 2. And cotangent is y over x, x over y, so that's -1 over 1 is -1. Okay, what if we wrote, and by the way, that one way we could get the angle to there was to rotate 3 pi over 4. Of course, we could also rotate it as pi over 4, 2 pi over 4, 3, 4, 5 pi over 4 negative. Negative 5 pi over 4 is another way we could get to the same place. Are there many other ways of getting there? How about if we go down here to the fourth quadrant? One way we can get there is on a rotation of negative pi over 4. That still gives us a reference angle of pi over 4. All of these different ones where we're looking that are, straight through, halfway through the middle of the coordinate, between the coordinate axes, okay, those will have a reference angle of pi over 4 or 45 degrees. So we can get here, for example, by rotating around negative pi over 4, or positive, if we go here, positive 7 pi over 4. Okay, well, what do we get? That coordinates of that point right here, where the circle of radius square root of 2 meets, is an r of square root of 2, an x of 1, and a y of -1. And using those values here, we can find the trig functions of that. Cosine, again, is x over r, so it's 1 over square root of 2. Sine is -1 over square root of 2. Tangent is -1, y over x. Secant is, let's see, r over x, so that's square root of 2 over 1, it's square root of 2. Cosecant is r over y, square root of 2 over -1 is negative square root of 2. Cotangent is x over y, 1 over -1 is -1. In a similar manner, we can get to the third quadrant here with the same reference angle by rotating. One way we can do there is -1, 2, 3 pi over 4s, -3 pi over 4, or if we rotate in the positive direction, that's pi over 4, 2 pi over 4, 3, 4, 5 pi over 4 would be another way. So those are the two shortest, the shortest positive, the shortest negative rotation to get there. And of course there's other ways to get there. Again, we can go around many times, doesn't matter, as long as whenever it stops right there, going through that point. What is that point? Well, that's the point -1, -1 for x and y. The r is square root of 2. And you can see that we worked these things out here. Notice that the cosine of all four of these angles has the same absolute value. In other words, the x and the r here, the r's are always the same size, and the x's are either 1 or -1. So these two guys over here, if it's in the if it's over here in the quadrants 3 or 4, no, 2 or 3, x is negative, so cosine's negative. Whereas if it's over here, cosine's positive. But they have the same absolute value either way. They're 1 over square root of 2. In this case, the complementary angle is the same size, so the sine and cosine are the same size, and the tangent is an absolute value of 1. And so these remember the tangent of the angle is the slope of this line here. So this line has slope 1 and this line has slope -1. Now, I can actually, instead of looking at it here, I can also look at these values on the unit circle and find the points here where it meets the unit circle. And so notice that the unit circle, the point here where it crosses the unit circle, has x coordinate the same as the cosine and y coordinate the same as the sine. So let me hide a few things here to make it a little bit easier. So we see that the coordinates here of this point on the unit circle are just x is 1 over square root of 2, y is 1 over square root of 2, and r is 1. So we can do this from the unit circle, but it's actually, I think, a bit easier. Okay, instead of working with the unit circle, it's easier for me if we just work with the circle of square root of 2 for radius. Okay, so those are the ones that have a reference angle of 45 degrees, or pi over 2 radians.